Good morning, everybody. All right, this is a demonstration I put together for you guys, hopefully to try to illustrate different temperature scales and the difference between Kelvin and Celsius. And so what I've done on my driveway is I've laid out some gumballs a foot apart. For those of you who don't know gumballs, they are the seed pods of a certain kind of tree. Let me see if I can show you just for anybody who cares. All right, that's a gumball tree. It's a sweet gum tree, and they drop little gumballs. And gumballs hurt like heck when you step on them, and they make new gumball trees, and other than that, they're really only good for throwing at people. But I decided to find a use for them. So I've laid out gumballs all along my driveway, all right, about a foot apart. So this is the bottom one, right here, and I'm calling this absolute zero. Absolute zero is the temperature at which all particle motion stops. It is the coldest possible temperature, all right? When motion stops, what's your speed? What's your velocity? It's zero, okay? You can't get more, you can't get slower than zero, okay? So it's zero, it's stopped, okay? You can't go slower than stopped. So this is what we call absolute zero, this gumball right here. And the Kelvin scale uses that as zero. All right, so now we're going to start walking. Each gumball is representing 10 degrees on the Kelvin scale, okay? So we're walking. It's a lot of gumballs, right? We're going to keep going. All right. You guys get to see a little bit of the garden I'm trying to plant. Okay, and here we go. We have gone past 27 gumballs. And we have reached the point at which water freezes or ice melts. We're going up in temperature, so for us, ice is melting here, okay? So we've traveled 273 degrees Kelvin, but this is where Celsius has started its scale. This is 0 degrees Celsius. It's the same temperature. It's just two different ways of talking about it, okay? All right, so we have 0 degrees Celsius. We have 273 degrees Kelvin. It is the same thing. This is the temperature at which water freezes or ice melts. We are going to keep climbing, okay? We are going to go past 10 gumballs, okay? And at 10 gumballs, we are now at the point where steam condenses or water boils. All right, so for us, water's boiling. We're traveling up in temperature. We have traveled 10 gumballs. That's 100 degrees Celsius. That's 373 Kelvin, okay? You notice that both of them have gone up by 100 degrees. So the size of a Kelvin and the size of a degree Celsius, they're equal. They're the same size, okay? We've got 1 foot between these gumballs because that's how big my ruler was. Why is Kelvin so much different than Celsius? Well, Kelvin started in a different place. Let me swing around. If you guys remember, we walked through 27 different gumballs, okay? There's that starting place all the way down there. That's where Kelvin started counting. So Kelvin got through 273 degrees before it ever reached the point of ice melting or water freezing, and that's where 0 Celsius is. The size of the degrees, this distance between the gumballs, is the same for both of them, but one of them starts in a different place. Kelvin starts all the way down there. That's what Kelvin calls 0. So by the time Kelvin reaches what Celsius calls 0, Kelvin's already been walking for 273 degrees, or 227 gumballs for us. So a couple things to remember about Celsius versus Kelvin. 0 degrees Celsius is the temperature at which water freezes or ice melts, okay? 0 degrees Kelvin, let me swing around here and hopefully I'm not making you guys too dizzy. 0 degrees Kelvin is all the way down the hill, down here. 0 degrees Kelvin is the coldest possible temperature. Now we can measure this in Celsius too. Let me get my marker out here. But in Celsius, we had to go 273 degrees below 0. So we're at minus 273 degrees Celsius. So I hope that helps you guys to understand the difference between Kelvin and Celsius. I hope that helps you guys to understand that the size of the degrees, the distance between the gumballs, is the same for both scales. Kelvin uses different numbers because Kelvin starts in a different place. Kelvin starts all the way down here. We travel through 27 gumballs. Keep going. All right. We've gone through 27 gumballs to reach here. That's why Kelvin's at 270. This is where Celsius starts. That's why Celsius is at 0. We're going to travel through 10 more gumballs. That's 100 degrees for both of them. Each gumball is 10 degrees. And now we're at the point where water boils. That's 100 degrees Celsius. But remember, Kelvin started earlier. So Kelvin is at 373. They both went up by 100. All right. And I hope that helps. Bye-bye.